Yes. Now alkane, alkene, alkyne. Now if you observe, alkane means all are single bonds. All are single bonds. There is no double bond and a triple bond at all. All are single bond. Single bonds means all are always single bond, means it is sp3 hybridization always. This carbon involved in sp3 hybridization. I already told you what is sp3 hybridization. Now coming to the alkene. Double bond will be there. How many double bonds? One double bond will be. If the compound containing at least one double bond, you can call as alkene. So, double bond is present in where? Alkene. Double bond is there means that carbon exhibits sp2 hybridization. That carbon exhibit sp2 hybridization. Right. Coming to the alkyne. Alkyne means a triple bond is present. Triple bond is present. Triple bond is present means sp hybridization. sp hybridization. Now we are going to write how to write the organic formula. How to give the name of that organic compound. Carbon is there. Carbon. For example, how many carbons you want, you can write. Now, this is the formula with all single bonds, means nothing but bond between carbon and carbon. All are single bonds. What is the remaining bond? Carbon should have 4 bonds. Carbon should have 4 bonds. It's compulsory. So the remaining here, how many bonds are there for carbon? Only 1 bond. Means remaining 3 bonds with hydrogen. Here how many bonds are there? This side 1, this side 1, 2. Remaining how many bonds? 2 bonds. 2 bonds with hydrogen. Here 2 bonds are there. Remaining 2 hydrogens. Here 2 bonds are there. Remaining 2 hydrogen. Here 2 bonds are there, remaining 2 hydrogen. Here only 1 bond is there, remaining 3 are hydrogens. I hope you understand. Right. Now this is elaborated form. We are elaboratedly each and every bond formation we have written. No need to write like this. We can write CH3. Because this carbon with 3 hydrogen, CH3 bond CH2 bond CH2 bond CH2 bond CH2 bond CH3. You can write like this: 1, 2, 3, 4, 5, 6. 4, 5, 6. Right. Okay. This bond is between, this you need to understand. This bond is between hydrogen and carbon. No, not like that. This bond is between carbon and carbon, like this only. But in short form, we are writing like this. This is short form. And this also you can write as CH3, CH2, 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 CH3. This also you can write. Without bonds also you can write. But it doesn't mean that there is no bond. There the bonds are present. We are not representing. That only the meaning. Okay. So, compulsory bonds are there between carbon and hydrogen also. So, all bonds are present, but we are not representing. This is called as shortest form. Now, one more indication also there. That is carbon. How many carbons are there? 6 carbon. 1 carbon. second carbon, third, 4, 5, 6. If you observe, every edge is having the carbon, right? 1, 2, 3, 4, 5, 6. 6 carbons are there. Here this carbon is having only one bond. This line represent a bond between this carbon and this carbon. Remaining 3 bonds with 3 hydrogens. Here 3 hydrogens are there. Carbon. Here carbon is there. 2 bonds are there. CH2. Here CH2. Here right CH2. Here CH2. Here CH2. Same formula only, but we are writing in the form of line structure. This is called as line structure. Line structure. I hope you understand. This is the way to write the chemical formula, organic formula. And second example, CH is there. Which representation is this one? Shortest form. This form, there is no bonds, right? Right. Carbon is there. Each carbon is having hydrogen, means one bond with the hydrogen. Is it correct? And is it satisfied valency for carbon? Carbon should have how many? 4 valency. But here carbon is satisfied with 2 valency. Is it possible? No. What is the meaning of this one is their triple bond. Their triple bond. This also they can write as C2H2. Also they can write, no problem. C2H2. Here triple bond is there. I already told you. Triple bond is there means what is the hybridization for carbon? Yes, very good. sp hybridization. Each carbon involved in sp hybridization. And one more example I am giving. One more example, third example. C2H4 is there. C2H4. Before going to C2H4, what is the formula of this one? How many carbons are there? C6. 6 carbons. Hydrogens, please count it. 6, 10, 14. H14. H14. C6, 14 is the formula of these structures. Number of carbons and a number of hydrogens. That's all. Now, here number of carbons are 2, hydrogens are 4. Write the structure. Carbon, bond with carbon. Each carbon, C is bonding with 2 hydrogens. Equally, they are distributed. If there is any difference is there means they will give. And is it satisfied? 4 valency for carbon. Is it satisfied? 1, 2, 3 bonds. So double bond. Double bond should be there. What is the example? This is example for alkane, because all are single bonds. There is no any double bond. This is example for alkyne with a triple bond. This is example for alkene. This is example for alkene. Now double bond is there means I said one hybridization alkenes, sp2 hybridization each carbon. Each carbon is having sp2 hybridization. I hope you understand. For example, I am writing CH3 bond CH2 bond CH double bond CH CH2 bond C triple bond CH. This is the compound. What is the molecular formula of this compound? What is the molecular formula of this compound? Tell me. 1, 2, 3, 4, 5, 6, 7. C7. Hydrogens 3, 2, 5, 6, 7, 8, 9, 10. H10. We should not call as this one alkane, alkene, alkyne. This is the mixed compound. This is mixed compound. Now, I want to know What is the hybridization of each carbon? If you observe first carbon, all are single bonds. 4 sides you need to see. Means like this you need to see. 4 sides. Is this single bond or is there any double bond? All are single bond. Very good. So sp3 hybridization for first carbon. sp3 hybridization. Come to the second. Single bond with 2 hydrogens also always single bond. So sp3 hybridization. Come to here. One single bond, one double bond. Double bond is there. sp2 hybridization. Right. Here double bond, here single bond. With this carbon, double bond one side, single bond one side. All means it is having the double bond. So sp2 hybridization. Either this side or that side, wherever it may. Here, come to here. Here single bond, 2 hydrogens also single bond. sp3 hybridization. Right. Here single bond, here triple bond is there. sp hybridization. Here triple bond is there. sp hybridization. I hope you understand. And I have one more question. How many sigma bonds and pi bonds are there? We already discussed about this in chemical bonding. Tell me how many sigma bonds. Sigma bonds along with the hydrogen also you need to calculate. Means this hydrogen you can write as one hydrogen here, one hydrogen. This hydrogen here. This hydrogen you can write here to calculate the sigma bonds. One hydrogen, one hydrogen, one hydrogen, wherever it may be. Sigma bonds, count it. All single bonds are sigma bonds. Double bond is there means one sigma bond and one pi bond. Triple bond is there means one sigma bond, two pi bonds. Two pi bonds. Now count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in double bond, one sigma bond. 9, 10, 11, 12, 13, 14, 15 in triple bond, one sigma bond. 15, 16. So 16 sigma bonds. Now come to the pi bonds. Pi bonds where it is here, not there, double bond. One pi bond, because in double bond one pi bond is there. One pi bond, here 2. 2 plus 1, 3 pi bonds. Sigma bond 16. I hope you understand. Now we are going to know the functional groups. Functional groups. What is the functional? Organic compounds, I already given CH3, CH2, CH3. For example, this. Is there any extra element is there? No extra element, only carbon and hydrogen. This is called as hydrocarbons. This is called as hydrocarbon. If we are giving any another element, chlorine, or otherwise any another oxygen with hydrogen, this type of molecules, one atom or group of atoms, if we are giving to the molecule, because of this group of atoms, the whole properties will be changed. The whole properties means its melting point, its boiling point, and reactivity nature, everything will be changed because of presence of this group of atoms. That type of groups are called as functional groups. Means functional group decides the properties of the compound. So what is functional group? Which decides the properties of the substance, of the organic substance. Organic substance is called as a functional group. How many functional groups are there? What is that name? We will discuss now. Before going to the functional group, see, I explained CH3, CH2, CH2, OH is there. It decides the functional. Right. Very good. Now I am CH3. CH3. Now did I add any external, any other element? No. Other element not added. Carbon and hydrogen. Okay. There is no any extra element is not there. Only these two elements only, but I added extra. I added extra. These type of extra groups are called as substituents. Substituents. Substituents means in place of one hydrogen. Actually, this is the formula. In place of hydrogen, I am adding CH3. Is it right or not? That is called as substituent. So, what are the substituents that we need to know? Substituents, for example, you can add as CH4. What is the CH4? Alkane. What is the name? Meth plus ane, methane. Methane. Methane, if you are removed one hydrogen, we will get CH3. Why I used CH3? If you write only CH3, CH3 is not satisfied with 4 valency. Only 3 valency is there, right? So, 4th valency is not there. So, it is not satisfied. So that this end we are going to connect with another compound. So that bond CH3. Bond CH3. Now, this is alkane. This is alkane. Is it correct or not? Alkane. By removing one hydrogen, we will get alkyl. We will get alkyl. Alkyl means methane, methyl. Methyl. For example, C2H6, ethane. We will get by removing one hydrogen, C2H5, ethyl. Ethyl. These are called as substituents. These are called as substituent. Ethyl also we can write as CH2, CH3. Like this also we can write ethyl group. And chlorine. If you add chlorine, that name is chloro. Chloro. Bromine, bromo. Chlorine, fluoro. Iodine, iodo. All these are we are using as a substituent. So these are not comes under to the functional group. So that I given the name here itself. I hope you understand. Now coming to the functional group. What are the, now I am writing functional group formula, name, prefix, suffix. What is meant by prefix and suffix? Prefix means before the name. Before, why I am writing here? Can I write here? Prefix. Before the name. We are writing this name at before of the molecule. Before the name. Suffix. End of the name. End of the name. Just you can remember like that, no problem. First one, OH. I already told you, if we used the bond, this end is going to connect with any another group. That is the meaning. So OH group. OH name is called as alcohol functional group. Alcohol functional group. Alcohols we are taking, no, that alcohol is OH functional. Prefix is hydroxy. Suffix is ol. Ol, that's all. And CHO is called as aldehyde. Aldehyde. Aldehyde prefix is formyl. Suffix is, what is the suffix? Al or aldehyde. Aldehyde. And CO CO means ketone. The name of this one is ketone. Ketone, oxo and one, and COOH, carboxylic acid. Carboxylic acid. Carboxylic acid, and this is no suffix, no prefix, suffix is oic acid. Oic acid, and bond NH2, amine. Prefix is amino, suffix is amine. And NO2, nitro group. Nitro group. Only prefix is there, that is nitro. That is nitro. After that, CN, cyano. CN, cyano. CN, cyano group. Prefix is cyano. Suffix is nitrile. Suffix is nitrile. NC, name is isocyano. Name is isocyano. Prefix is isocyano. Suffix is isonitrile. Isonitrile. These are the functional groups we are using in our organic compounds. More is there, CONH2. This is called as amide. Amide. This is prefix is carboxyamine. Carboxyamine. And this is amide. This is amide. These are the functional groups. And preference order. Preference order. And two more functional groups are there. This is O means here alkyl group. I already told you CH3 is there, or CH2, CH3. Whatever group we are going to add to the functional group, this group is called as alkyl group. We are indicate with R. R means R is equals to alkyl group. Alkyl group. For example, if you want to understand CH3, CH3, OH is there. Now OH is attached to the CH. The whole group we are calling as alkyl group. Simply we can write as ROH. Simply we can write as ROH. That is called as alkyl group. So two alkyl groups are separated by oxygen. That is called as ether. That is called as ether. The no prefix, nomenclature for suffix is ether only. Ether, right. This is COO or CO, two alkyl groups with COO group, that is ester. Ester. O8. 8 is the prefix for, suffix for ester. And now coming to the functional group priority order, which is more priority in these all functional group, which is most preferable is carboxylic acid. After that amide, amide means CONH2, cyano, CN group, aldehyde, CHO group, ketone, CO group, alcohol, OH group. After that amine, NH2, ether, ROR, ene, double bond, ine, triple bond, halo, any halogen, either fluorine, chlorine, bromine, iodine, anyone, and nitro, NO2 group. All these are the preferential order. Preferential order. Now, why I given all these list? Because we are going to the nomenclature of organic compound, which is very important.